Hello viewer, welcome to Primary 5 lesson, Social Studies. My name is John Lucas Modi, and today we are going to discuss a new topic. We are beginning a new topic. We are following our booklets, remember, and today we are beginning from page 26. So kindly open your book to page 26, that's where we have that lesson picked for. So when we are looking at physical features, we are not beginning a new topic to us who are in primary 5. In primary 4, we learned about physical features in our district, and also in primary 3, we learned about physical features. So it is not something which is new to our ears. I'm so sure about that. So when we are beginning with this topic, we need to understand, one, the definition of physical features, which means in the first case, we are going to have a definition of physical features. Like I said, you learned about this in primary, in the downer classes, which means you should be now able to give the meaning of physical features. What are physical features? The answer is physical features can simply be defined as the landforms of an area. That is how simple we are going to give this definition. Physical features are landforms of an area. Physical features are landforms of an area. Which means we are also getting another thing here. We are saying physical features are landforms. Which means if we are asked another question, what is the other way for calling physical features? Or what is another name for physical features? Then we should know that the other name for physical features is landforms. That is what we need to understand. Now, physical features are grouped into two. We are going to look at the two groups or types of physical features. Types, or you can call them groups of physical features. I want you to be very careful with this heading, because sometimes we children end up mixing these things. We are having the types of physical features, and then we are going also to look at the examples. The types are different from the examples. So those are two different things that we shall be looking at. First, we are beginning with the types. Number one, we have what we call relief physical features. Relief physical features. We have relief physical features. This is the first type we are going to look at. Remember here, we are only going to talk about two types. And we are saying we have relief physical features. Sometimes we can write them as relief features. Not only relief, because if you write only relief, then you will be writing a different thing. So we have relief physical features. Now, what are relief physical features? Relief physical features are those landforms that are raised above the ground level. Let me write it down. Relief physical features, we are saying, are the landforms. These are the landforms of an area raised above the ground level. So that is how we simply define relief physical features. I want you to enjoy this lesson very well as you understand. So we have said we have two categories, two groups or two types of physical features, and we are looking at the first one. We are saying relief physical features, and we are saying relief physical features are landforms of an area raised above the ground level. Now, let's look at the examples. Which are these physical features? Which are these landforms that are raised above the ground level, forming that group that we call a group of relief physical features? So we are going to have the examples of these landforms which are raised above the ground level or above the earth's surface. We would also call this above the earth's surface. Earth's surface. So we look at these physical features. Which ones are those that are raised? If I were to ask you, which physical features are those that we find raised above the ground level? You will find that here we shall have examples like mountains. Of course, a mountain is a raised area. It is not just down, but it's raised. So a mountain falls as an example of a relief physical feature. The other example of a relief physical feature is a hill. We have it called a hill. So that is also the second one, hill. In plural, we shall now look at hills, meaning we are now talking about many of them. Apart from hills, we also have others. We have what we call plateau. We have plateau. And I want you to take serious note of the spelling plateau, because it can make you not to get the mark that you are meant to get. So we have plateau. As also, remember when we are defining a plateau, even in the primary 4-3, we say a plateau is a raised flat-topped piece of land, meaning it is raised above the ground level. So that is another example. Then we also have what we call highlands. We have highlands, and then we can have what we call the inselbergs. We have the inselbergs. The inselbergs are these are the isolated hills on plains. That is how we simply define an inselberg, an isolated hill on the plain. So for that case, we have got these features which are raised above the earth's surface or raised above the ground level, and we have called them relief physical features. So let's go and look at the other type. Remember that has been type 1 as relief physical feature, meaning we are now going to look at the second one. What is the other, or which is the other second one? We are going to look at what we call drainage physical features. So we are having our second type, our second category, or our second group of physical features, and we have called this one's drainage physical features. Like I said, you can't only write drainage. If they ask you to write these physical features, don't say drainage, because when you write only drainage, you will be meaning something very different from drainage physical features. Why? When we are looking at drainage, we are looking at the underground water system. That is how we define drainage, the underground water system. But when we are looking at drainage features or drainage physical features, we are meaning landforms that contain water in the simplest way. Just like when we were defining relief physical features, we say you cannot say only relief, because if you only write there relief, then relief means something which is very different. Relief, we define it as the general appearance of the landscape, which means it is different from relief physical features, because here we say relief physical features are landforms raised, whereas relief alone means the general appearance of an area. Now, we have already given a definition. We are saying drainage physical features are landforms of an area. These are the landforms of an area which contain water. Which contain water. That is how simple this lesson is. Landforms of an area which contain water. Now, having understood landforms which contain water, and you now go to your general examples of physical features, you will be able to trace which ones have water, which ones are those ones which are containing water, and you will be able to give very many here. So, if we are to discuss, you can give me one. You will find that here we can have lakes. Let's first write a heading. Examples. Examples of these drainage physical features. We are saying we can have lakes here. We can have rivers. We can have streams. We can have oceans. We can have seas, and many others. So these are the ones we call drainage physical features. I have said drainage physical features are the ones that contain water. They lie on the surface of the earth, meaning they are found just down. They are not raised as for the case of the other ones which were the other ones that we talked as the relief features. Now, having looked at this, let's now have the general examples of physical features. Of course, now the general examples, we are now going to include both the other ones which are relief features, and we add these ones which are drainage features. So let's have a subheading that will make us summarize examples of, let's have it as general examples of physical features. So we are going to give the general, we are saying here we are now putting both relief features and drainage features. So we begin listing them. We began from this side. We say we have got mountains, we have got hills, we talked of a plateau, and others, we talked of highlands. We continue. We had inselbergs. We are adding lakes. We are adding rivers. We have oceans. We are continuing. We have plains. We have the Rift Valley. We have the valleys. We have Rift Valley, and then we have the valley. They are not the same. These are two different features. We shall be discussing them. And I'm so sure you learned about valleys, a low-lying area between hills or mountains. You must have finished this. We shall only be discussing more about a Rift Valley. Then, which other ones have been added? We have not put here seas and many others. So, all these give us the general examples of what we call physical features. Now, having looked at that, we are going to understand these physical features one by one. We are going to talk about them in detail, and we shall be looking at them one by one. And the first one is, we are beginning with a plateau. When we check on our books, on page 27, it gives us a plateau as the first physical feature for us to talk about. So can we turn to that and we discuss what we mean by a plateau? So our topic, our subtopic of discussion is a plateau. Now, having looked at this, we are going to ask ourselves, what do we mean by a plateau? Of course, like I said, this is just a revision. We talked about this. We said in the primary 3, primary 4, we understood that a plateau, what is very important is for you to take serious note of this spelling. A plateau is a raised, this is how we begin, raised, flat, topped piece of land. Raised, flat, topped piece of land, which means we are looking at raised, flat, topped, and that is how we get it is map symbol. So in case we are asked to draw, as we can see on that page 27, they have drawn for us the symbol there for a plateau. That symbol gets for us a definition. Raised, flat topped piece of land. This is what we call a plateau. And this is the map symbol for a plateau. This is how we represent it. Now, having looked at that, we are going to look at which other physical features are found on a plateau. Now, on a plateau, we have almost all these other physical features. Because we say raised, flat top. So we are going to have other physical features found here. And for that case, we shall be looking at which activities or which economic activities can be carried out on a plateau. So that is our next subheading that we are going to be having. Activities done on a plateau or carried out on a plateau. So we are continuing. We said we are going to be looking at these economic activities or these general activities which can be carried out on a plateau. Remember, we said on a plateau we can have other physical features. So because of that, whereby we have other physical features like mountains, hills, so we are now saying that that area can be having the fertile soil which can support the growing of crops. So we call that one cultivation. Cultivation. Cultivation simply means crop growing or the growing of crops. Of course, this one we can take it under farming as an activity. Then because of this, we also have tourism. We have tourism. This plateau can be having some forests that can support lumbering, so lumbering also becomes possible. It can have some water bodies, meaning fishing can be possible. We have fishing, and also we have settlement. People settle. Settlement. Can have settlement, we can have construction, that is road construction, and construction of industries also is another activity that can be done on a plateau. So, next is, we are going to look at another physical feature, and for this case, we are going to discuss, let's begin with mountains as our second example of physical feature. So our second physical feature, we are going to discuss mountains. We are going to talk about mountains. Now, we all know what a mountain is. We have all seen mountains, but what I'm so sure of is some of us cannot define what a mountain means. So, what is a mountain? That is what we are beginning to understand first. What is a mountain? Or how do we define a mountain? Someone will be like, even there is a definition for a mountain. A mountain is a raised piece of land. A mountain is a raised piece of land which is higher than 2,000 meters. That is how we can simply define a mountain. Remember, mountainous areas or areas which are high above the ground level, that is now what we call the altitude. That is the height of land above the sea level is determined by what we call altitude. And I mean by that altitude is determined by the instrument that we call the altimeter. So for that case, we measure if this raised piece of land is higher than 2,000 meters, then that qualifies to be a mountain. So we are going to look at which are these mountains that we have in Uganda. First, before we look at these examples of mountains, we are first of all also going to understand that in Uganda, we have two types. I say types, not examples. I told you at the beginning of this lesson, there is a very big difference between the types and the examples. And you have to be very careful when you are writing your questions. When you see type, you need to first pause and you think again, you think properly. Types, which are the types and which ones are the examples. So we go. We have got types of mountains. Types of mountains that we have in Uganda. Types of mountains in Uganda. So in this P.5 Sst class, we are going to say that we have two types of mountains in Uganda. Which are these types? I know you must be running to give me the examples, but I have stopped you from that. I have said there is a big difference between the examples and the types. So when we come to the types, we look at the formation. How was this mountain formed? Therefore, we have what we call block mountains. Block mountains. And then we have those mountains which were formed as a result of volcanic eruption or volcanicity. We call them volcanic mountains. So these are the two types of mountains that we have in Uganda. I want you to be very careful with this. Understand that Uganda has got two block mountains that we can also call fault mountains or host mountains, and then we have volcanic mountains. Now the block mountains, something which is very interesting about block mountains is that these are mountains which were formed as a result of, mountains formed as a result of faulting. We shall look at how the faulting began and how it ended, and at the end of it all, a block mountain was formed. But before we look at that, I want you to understand that Uganda has got only one block mountain. So if a question is asked you in your examination paper, name the only block mountain in Uganda, that is Mountain Rwenzori. It is the only block mountain, which means the rest of the mountains we have in Uganda are volcanic mountains. That is something which is very, very nice for you to hear. So when we look at block mountains, we are saying these mountains were formed as a result of faulting. So our writing, we shall say, these are mountains which were formed as a result of faulting. That is what we need to understand. So we are going to look at what do we mean by faulting. What is faulting? This is a process that led to the formation of block mountains, but it's not how we define it. So if we are asked, what is faulting? Faulting, we are looking at the breaking of the earth crust, or the earth crust cracking or breaking, and the fault lines created. Let's look at how these mountains were formed. Now, we are going to have our illustrations. We are going to have our illustrations showing the earth, that is how the earth appeared. So, we are going to have our earth. We are going to look at the stages. So let's say this is how the earth appeared before cracking. So we are calling it stage 1. Stage 1. This is what happened. Now, here we are going to look at the forces acting on this earth. We are going to look at the forces. Here we have two types of forces that led the formation of these mountains. We have what we call tensional forces. You will be asked, name any two forces or name any one force responsible for the formation of block mountains. We have tensional forces, and then we have what we call compressional forces. Compressional forces. Now, what is the difference? The difference is tensional forces pulled this earth crust aside or sideways, which means we can have the forces drawn like this. When you see this kind of a drawing, you know this one is representing tensional forces. They are pulling this earth suck all this earth sideways, and as a result of pulling, just like you were the one, you would find that if someone pulls you from this arm, this side, another person also takes this side, and they begin pulling you. At the end of it all, you will find that you might end up getting, or your arm ends up getting detached from your body. So we are going also to look at this. Let's look at this formation through compressional forces. We have seen tensional forces, they are the ones that pull sideways. Now we look at what we call compressional forces. When you see this drawn and these arrows are facing inwards, those are what we call compressional. Compressional means they are now squeezing this earth from sideways, and as a result of the squeezing, we are going to have it beginning to develop cracks or tear, and at the end we shall have some part squeezed to go up or to rise up. So this was stage 1. We are saying in stage 1, forces were acting on both sides. Forces are acting on both sides. Now, in the second stage, we shall use this very diagram. In the second stage, we are going to have these forces developing. We are going to have cracks developing on this land. So we are having cracks. These cracks are the ones we call faults. So this is now, we are now in the second stage. Maybe let me draw different stages. You might fail to get it well. So let me leave this first stage. So let me have the second stage here. The first, we were having it shaded like this. Second one, we had it shaded like this. And then the third layer, we had it shaded like this. So we are going to see in the other first stage, we said in the second stage now, that is stage 2, remember we are having these forces continuing to push this earth from both sides. We call it squeezing it from both sides. Due to the continuous pressure, this earth is going to develop cracks, as we say in the other previous one. So we are having cracks developing here. These cracks develop. So in our writing, we can now describe this by saying cracks, and these cracks here are the ones that we call faults. Remember, we talked about faulting. We are now understanding the process of faulting, how it took place. So we are having cracks or faults developing. And that one is due to the continuous acting of the continuous pressure that is mounted from both sides. So that is stage 2. Now in stage 3, when these forces continue acting, these cracks will join or will become completely, or they will join completely, forming a complete tear. That's now what we call a fault. Now, after that complete tear, this middle part will be pushed to rise it up, meaning we are going to have our diagram drawn like this. The middle part is pushed up, whereas the other part, the sideways, remains. So the first shading, we had it like this. It has been pushed. That one now is the one which is down here. The middle part has been pushed up and the other one has remained down because of the complete tear. Then the second one, we had it shaded like this. Now for this one, this one has remained here. Remember the other one has been pushed up. So that layer is here of the earth. And then the last one, we had it shaded like this. So that one is this layer here, which has also remained down here. At the end of it all, we are going to have the mountain, our mountain illustrated like this. Now, this part which is pushed or which is squeezed and it goes up is the part now that we call a block mountain. This is now a block mountain that we can also call a host mountain. Please note, as I said, that for us in Uganda, an example of such a mountain is Mountain Rwenzori. So we are saying note, because I don't want you to mess up with this. Mountain Rwenzori is the only, I have even underlined only, is the only block mountain, in where? In Uganda. I'm not saying in the whole world. I'm not saying in East Africa. I'm not saying in Africa. But I'm saying in Uganda, the only block mountain we have is Mountain Rwenzori. And I'm so sure you have understood that Mountain Rwenzori was formed as a result of what? Faulting. Because it is a block mountain. And I'm glad that we have understood how faulting took place and the whole process on how it came to be a mountain. So that is about block mountains. Can we now cross to the other type of mountains that we looked at as volcanic mountains? Let us also talk about volcanic mountains. So, for volcanic mountains, we are going to look at how are volcanic mountains formed. Now, volcanic mountains were formed as a result of volcanic mountains were formed as a result of volcanicity, or we can call it volcanic eruption, which means here we are going to look at eruption taking place. Now, eruption means the coming or the getting of the magma that is from underground, that is from the earth, from down, and that we have that magma getting out in form of lava, which means we shall understand that if, for example, this has been the earth's surface, and of course this is the ground level, so we shall be having magma down this way. We call it a molten liquid, that is magma. So because of the pressure, this magma will have to be pushed to come out, and you will find that it will open the earth and it comes out. Now, as this magma is coming out, when it comes out, it becomes what we call lava. It becomes lava. Remember, it comes out and it continues flowing sideways. And as it continues flowing sideways, it keeps on piling. At the end of it all, you will find that this lava will solidify. That is the spelling of lava, not the other one that we have in science. We have this one. As a result of that, it will solidify and it will become a mountain. Therefore, when we are having such a diagram, we shall be having, you always have a diagram drawn, and you will find that here there can be we have the pipe here where this lava flows, and you will find we are going to have our diagram drawn like this. So, like I said, there is this pipe here which takes this lava, where this lava passes going out. We call it the pipe. And we are having these outlets where the lava can escape, and we are having this now fire. So this is lava which has solidified to form what we call a mountain. And at the end of it all, we shall also understand that when this mountain solidifies, when it cools, of course, the lava which was now trying to get out might also end up now solidifying here, and there will be a hole created, which when rain comes, this hole will collect water and it will become a lake. And this lake will be the one we call the crater lake. We shall come to talk about that when we are talking about lakes. So this is how eruption takes place, giving or resulting into the formation of what we call volcanic mountains. Now, as we continue, we also need to note that in volcanic mountains, we are having types. We have types of volcanic mountains. Types of volcanic mountains. What is very important for us to understand in our class is, are we able to tell the types of volcanic mountains? We are having three. There are three types of volcanic mountains. We have what we call the active. Remember, these volcanic mountains, we can also call them volcanoes. Volcanoes, that is the spelling. Volcanoes, N-O-E-S. Volcanoes. So we have what we call the active volcanic mountains, or we can call these active volcanoes. And then we have extinct, that we can call the dead volcanoes. Dead volcanoes. And finally, we have what we call the dormant volcanoes. We shall understand these types very well, more so when we move to the next class. Now, having understood these three types of volcanic mountains, because you can also be asked, remember I told you the types are different from the examples. Now, we are going to look at which are these examples of volcanic mountains that we have in Uganda. So we are having examples of volcanic mountains in Uganda. Examples of volcanic mountains that we have in Uganda. Now, here we are going to look at the major volcanic mountains that we have in Uganda. For example, remember I told you that the rest of the mountains in Uganda are volcanic except Mountain Rwenzori, which is a fault or a block mountain. Meaning the rest, like we have Mountain Elgon, which has got its peak as Wagagai. We also need to remember this. We talked about mountains and their peaks. Mountain Elgon with its peak, Wagagai, which means this one is a volcanic mountain. Then the other one is, we have Mountain Mufumbiro, which has its highest peak as Karisimbi. Peak Karisimbi. You need to take this serious. We are having the mountains and their highest peaks. Then we have another mountain that is in the northeast called Mountain Moroto. Remember, we have Mountain Moroto. Which has its peak as Sokdek. So that is the highest peak of Mountain Moroto. Then we have other mountains. We have Mountain Napak. Remember Mountain Napak. We have Mountain Morongole. If you don't know where these mountains are located on the map of Uganda, kindly get your atlas, then you look for Mountain Napak, then you look for Mountain Morongole. You will be able to trace them, and other mountains that we are not putting now here. So these are the examples of what we call the volcanic mountains that we have in where? In Uganda. Remember, we have said Uganda has only one block mountain, that is Mountain Rwenzori with its peak as Margarita. Finally, as we are coming to the end of our lesson, I want us to understand the importance of these mountains. The importance of mountains. How are these mountains good to us? Importance of mountains. So we are giving how are mountains important to us? How are mountains important in an area? If an area has got mountains. Number one, remember, these mountains, we always say mountains, when you look at the mountain slopes, you will find that the mountain slopes always have fertile soil for crop growing. So we are going to take that as our first answer. Mountain slopes. Mountains have fertile. Let's see, mountain slopes have got the fertile soil. Mountain slopes have got the fertile soil that support crop growing. Which means on the slopes of a mountain we have fertile soil that support the growing of crops. For example, an example is, we always say the slopes of Mountain Elgon. Remember Mountain Elgon, we say it is a volcanic mountain. So those slopes have what we call volcanic fertile soil. This volcanic fertile soil supports the growth of crops. And I was saying an example is on the slopes of Mountain Elgon, people there grow what we call Arabica coffee. So we are saying, for example, on the slopes of Mountain Elgon, we have Arabica coffee. For example, Arabica coffee grows best on mountain, we can call it Mountain Elgon slopes. That is what we are also adding here about the soil fertility which we find on the slopes of these volcanic mountains. We are saying mountain slopes have got fertile soil for crop growing. For example, Arabica coffee. Be very careful with this. Some people write Arabic, not Arabic. It is Arabica coffee. Grows best on Mountain Elgon slopes. Secondly, these mountains have some wild animals Now, when you end your answer at this, mountains have some wild animals. We shall cross you. Why? This is not the importance, because these wild animals can be dangerous to people. Is it of importance? The answer is no. So you have to continue so that you can convince the person who is to mark your work that yes, this is really how important it is. So we are saying mountains have some wild animals that can be hunted. That can be hunted for food. Now when you complete like that, the person marking you will now understand that, oh, really this child is right. For sure, these mountains, remember some mountains have thick vegetation, they have many forests on them, so you'll find that these forests have these wild animals that people can go and they hunt. But when you just end it on the way, mountains have some wild animals. Does not come, because these wild animals can be dangerous to people. And will that be of an advantage? The answer is no. Next is, some mountains have vegetation on them which can help us with firewood, charcoal, fruits. So we are saying some mountains have got trees on them. Let me specify. Have got trees growing on them which provide firewood. They have trees growing on them which provide firewood. These trees can be, they can burn them to make charcoal and other benefits of the trees. So because of that forest, because of that, all those trees on that forest, on that mountain, we have this. Then the other one is mountains. Mountains attract tourists. Mountains attract tourists who bring income. That is another point. Mountains attract tourists. Remember, we have tourists who always go to tour mountains yourself. You can be a tourist as a P5 child. You can organize a trip with your teacher. You say, you are going to tour Mountain Elgon. You are going to tour Mountain Rwenzori. So when you go there as a tourist, of course, you will contribute some money to the government. So that is another importance. And then lastly, for now, we are going to have mountains helping in, mountains help in modifying the climate of an area. Mountains help in modifying the climate. Now, when we talk about modifying the climate, we simply mean through rain formation. How do mountains modify the climate? Mountains make the climate nice of an area. That is by helping in rain formation. In our next illustration, we are going to understand how do mountains help in modifying the climate, and our lesson will be ending there. So let us discuss how rain is formed in mountainous areas. Alright, so we are going to look at the illustration. That is how our words read. Illustration showing the formation of, sorry, I have repeated of twice. Fine. Illustration showing the formation of rain in mountainous areas. Which means we are going to look at, we have said mountains help to modify the climate. That is, mountains help in rain formation. But how does it happen in mountainous areas? So, in our illustration, we are going to have a mountain standing here. This can be Mountain Rwenzori, this can be Mountain Elgon, or any other mountain. So, our mountain is standing here. This is our mountain standing. Right? So we have our mountain here, standing. We have illustrated our mountain. Now, what happens is, remember, we always have the sun everywhere. The sun shines. Even in those areas, we shall be having our sun here. This is the sun. Now we are continuing. Now, you will find that in these mountainous areas, you can find there is a small water body, something like a water body. Can be a river,
can be a small lake which is having water. Now, we are going to have wind blowing across this mountain. Wind can be coming, for example, the wind comes from this side, and this wind is aiming at reaching to the other side of the mountain. Now, what happens is, when this wind is blowing, this wind is going to pass via this water body. This wind is going to pass across, or is going to blow across this water body. Remember, we are saying the wind blows to the other side. But now when this wind meets this mountain, you will find that that wind will not be able to pass through the mountain. So we were having the sun shining here. Remember, the sun is always having its arrows and they are always straight. So we are saying the wind is aiming at going to the other side of the mountain. But because of the blockage here, the mountain is there standing. The wind cannot be able to pass through that mountain. So what will happen is, this wind, having passed here, we said it will get the moisture. It will get some moisture from this water body. And now, it will be forced now to rise up. This wind is now rising where? Up. Instead of it crossing, the mountain is blocking it. So, it will direct the wind to go where? Up. And when this wind goes up, remember we are saying this wind is carrying moisture. It is going to lose that moisture into the atmosphere. And when it loses it into the atmosphere, of course, it will lead the formation of what? The clouds. Of which clouds will eventually result into the precipitation of the rain. Meaning, we shall have now this area receiving what? Rain. Rain has now come. That is how we are simplifying this drawing. Remember, this wind had its plan to go to the other side. Now, having lost the moisture into the atmosphere, this wind continues to descend. This wind, we can even have it now drawn in a different way. We can now have it dotted. Meaning that it is now moving without what? Moisture. Here it was having moisture. Because it had gotten the moisture from where? From this water body, from this river or lake. Now here, the wind is descending without moisture. We call that one dry wind descending. You can say dry wind descending. And because of dry wind descending now, we shall have that the other side does not now have rain. I want you to understand this diagram. When we are illustrating this rain formed in mountainous areas, we are seeing that it is only one side of the mountain which receives this rain. The other side of the mountain that does not receive, as we can see, but this side receives. Which means we need also to understand that a mountain has got two sides. When they ask you for the sides of the mountain, there now we look at the formation of rain in mountainous areas. There is a side of the mountain which receives the rain, and then there is this side which does not receive the rain. Now, the one which receives the rain is the one we call the windward side. Windward side. I believe you are able to see this well. Let me wrap so that you can see it well. We say this is the one we call windward side. Now, the other side which does not receive rain is the one we call the leeward side. We can simply call it the rain shadow. Rain shadow. Remember, a shadow is not a real object. For example, when you stand, maybe when you stand and the sun is shining, you'll find that your shadow will be somewhere. Is that you? No. That is your what? Shadow. So also here, we are having this side as the rain shadow. But it's not the real rain. The real rain is received this way. Now, we should also be able to answer another question. what type of rain is this that we have illustrated. This is the type of rain that we call relief rainfall. Not just relief, but we call it relief rainfall. This is relief rainfall. So for the other side, when you're saying that mountains help to modify the climate of an area, or mountains help in rain formation, we should be able to tell that that one is what we call relief rainfall. And in relief rainfall, one side of the mountain only receives the rain, the other does not. Which means, if I asked you another question, which side of the mountain is good for growing crops? Of course, you should be able to look at which side now. Is it the windward side or the leeward side? When you look at the leeward side, no rain. When you look at the windward side, there is rain. So the side which is suitable for crop growing is the windward side. Why? Because it receives rain. Then the other side is not good. Why? It does not receive rain. And does not receive rain because it only receives the dry winds. The dry winds descend the other side without the moisture. That is what we mean when we are looking at mountains. Thank you so much for having been a good audience in this lesson, and I believe we have enjoyed it all. For that, I wish you a nice time. Goodbye.